Okay, so now we're going to actually work some acid-base problems and kind of talk through some of those things we talked about in the acid-base balance talk. So you're going to have some sheets. I'm going to have to get a few things out to let you see. You'll have something that looks kind of like this, which is just a really nice handout. Save it forever and ever and ever because it's a really nice, concise view of acid base, and kind of everything you need to know is on this little worksheet, so take a look at that. You'll also have a set of problems. So you'll read through these and then you'll have some problems that you can work through. So this is kind of your homework, not for points, but homework for practice. So you'll want to do that. We're going to actually work some problems today. So we'll work these and then you'll go through and work those on your own, and I'll also post the answers so you'll know that you've gotten it right or not. So let's just do some problems, and I'm going to keep referring to my notes because when I'm trying to talk at the camera and looking at things, I don't want to mess it up and make sure I cover everything. I've got notes to make sure I explain to you. Usually I talk without notes, but this one's a little different. But there's just a lot to cover, and I don't want to miss it. Okay, so when we do acid-base problems, the first thing you want to imagine is that you are in a clinical setting and you're taking a blood sample, and you're going to first you want to look at pH. So the first thing you want to say is their pH even normal? So you want to say, is the pH in or out of the normal range? If it's out of the normal range, what's the normal range first of all? 735 to 745. Is it higher than 745, which would make it alkalotic or more basic? Is it below 735? Is it acidosis? So is it more acidic or more basic? Once you've looked at the pH, the next thing you need to look at is the carbon dioxide levels and the bicarbonate levels, because what's that going to tell you? If you look at bicarbonate and carbon dioxide is a respiratory issue, and bicarbonate would be a renal issue. Okay, so that would let you know, are you looking at a respiratory or metabolic issue? Okay, the next thing you want to look at is the other system trying to help? So if you're having a respiratory issue, are the kidneys trying to help? What are their values? If you're having a kidney problem, are the lungs trying to help? Are you hyperventilating, hypoventilating? Are you trying to change your CO2 levels to try to compensate? So are you fully compensated where the pH is normal and both CO2 and bicarbonate are abnormal? Or are you partially compensated where pH is just out of the normal range, that nothing's is able to help enough to keep pH normal? So I made you a cheat sheet. Now you can't have a cheat sheet in the test, but this is kind of the cheat sheet that you can look at and try to, I hate to tell people to memorize things, but this is one of those things you just have to try to memorize. So this is your cheat sheet. Okay, so pH is the level of hydrogen in the blood. Okay, so if it's below 735, you're in acidosis. That means you have a lot of hydrogen. If it's above 745, it's alkalosis, which means you don't have enough hydrogen. You have more hydroxyl ions. Carbon dioxide is a respiratory parameter. That's telling you it's a lung thing. And we know that because CO2 is carried in the blood. Okay, and we're blowing CO2 off using our lungs to breathe. If your CO2 level is below its normal value of 35, you're in alkalosis. You don't have enough carbon dioxide to make acid. Think about that reaction. Carbon dioxide plus water equals H2CO3, which breaks into hydrogen ions and bicarbonate. If you have too much CO2, you're in acidosis. You're making too much acid. Bicarbonate's the metabolic parameter. Okay, so remember, bicarbonate can suck up all those hydrogens. It's like a buffer. Okay, it can absorb those hydrogens. So if it's too low, you're in acidosis because there's just not enough to soak up those hydrogen ions. If it's above 26, but above the normal range, you're in alkalosis because it soaked them all up. So there's not any acid out there to make it be acidic. All right? Then you have to look at the compensation. And remember, the ability of the other organ system to fix the problem. Okay, this is your body's attempt to stabilize acid base. All right? If the pH is in the normal range, but CO2 and bicarbonate are out of whack, you're fully compensated. If pH is out of the normal range, you look to see if the other system is even trying. And I know it's really kind of hard to make sense of that until you actually do the problem. So we're going to do some problems, and I think it'll start to, the fog will lift and it'll make a little sense. Now, remember, you've got to know your normal blood chemistry. So normal blood chemistry is pH, bicarbonate, and carbon dioxide levels. So your pH is 73545. I'm going to give you that. That will be, I mean, I'm not going to give you that. That you have to memorize. I'm going to give you your normal CO2 levels. I'm going to give you your normal bicarbonate levels. So these will be on the exam. You'll have to plug in the pH levels. Okay, I expect you guys to remember that. So the first thing you need to do, step one, is really kind of set up your map. So when you're doing these problems, again, I will give you the CO2 and the bicarbonate, and then you'll fill in the pH of 735 and 745. So this is your low number and then your high number. Now, the first thing you need to do is kind of set up your second cheat sheet. You've got to take what you knew, what you learned on your cheat sheet. Okay, so if your values are out of whack, what does that tell you? So if you have a low pH, you are in, so if it's below 735, you're in acidosis. If it's above 745, you're in alkalosis. Okay? If your your CO2 level is too low, you're in alkalosis. If it's too high, you're in acidosis. And if your bicarbonate level is too low, you're in acidosis. And it's too high, you're in alkalosis. Okay? So I always do that. I just start with that. I set up my cheat sheet on my test. Okay, so if you're testing at home or even at the testing center, you can have a blank sheet of paper, show it to me to the camera, or the testing center people can provide you a blank sheet of paper, or you can bring one in. That way you can write this down. So you'll write in your CO2 and bicarbonate and pH levels, high and low. If you have it too low, acidosis, pH, alkalosis, carbon dioxide, acidosis, bicarbonate. If the values are too high, that gives you alkalosis for pH, acidosis for carbon dioxide, and alkalosis for bicarbonate. That's kind of the first step. Then we're going to start looking for matching values. All right, that's the next step. We're going to start looking at matching values. So how do we do this? Let's actually work a patient problem. All right, so here's what we got to set up. Okay, so what did we say? Acidosis, alkalosis, acidosis, alkalosis, acidosis, alkalosis. Okay, that's the first thing I always do. These are my patient values. This is the blood chemistry that you actually got from the patient. So then I write that into my equation. 7.29. Where does that fall? Does that fall between those values? No, it falls over here. Okay? Where does my CO2 level? Is it within those normal values? It's outside. Where's my bicarbonate? It's within. Okay? So these are my three values. Here and here. I've written them in. The first thing I want to do is look at the pH. So step one, what's the pH? We have what? Is it acidosis or alkalosis? It's low. So this last one is going to be acidosis. I can fill in the last blank because I know we're in acidosis. That's the first thing I can figure out. Now I've got to figure out why I'm in acidosis. What's going on? So you want to look at the match. Which one of these, of the respiratory and the metabolic, which one of these is causing you to be in acidosis? Which one is in the acidosis range? Too much carbon dioxide is what? That makes you acid. That's your problem. That caused it right there. That lets me know that this is respiratory acidosis. I'm kind of filling in from the back forward. So I know I'm in respiratory acidosis. Are the kidneys trying to help me? Well, let's look. The kidneys aren't doing anything at all. They're in their normal value. The pH, because it's not in normal range, it's outside of the range. There's no compensation going on. This is uncompensated respiratory acidosis. Okay, let's do another one. You'll get the hang of it. Don't freak out. All right, number 2. Let's do our cheat sheet again. So, acid, alkyl, acid. I need some kind of abbreviation for this. Alkalosis, acidosis, alkalosis. All right, where's my pH again? 7.49. So it's going to be outside the normal range. Where's my CO2 level? Within the normal range. Where's my bicarbonate level? Outside the normal range. So here, here, and here are our values. Step 1, look at your pH. Are you acidic or alkaline? You know you have alkalosis because you're 7.45. You're too basic. Which one's causing that? Which one is the match? Alkalosis, alkalosis. These two match. What does that tell me? Metabolic. Okay? Now, is anything happening? Are the lungs doing anything? No, because they're in normal range and the pH is still out of whack, so they're not even trying. Lazy. So uncompensated metabolic acidosis, alkalosis. Let's do number 3. So what do we do? Acid, alk. Acid. What? Alk. Acid. Alk. Okay? Where's our pH? 7.32. It's out of whack. Where's our CO2? Over here. Where's our bicarbonate? Ooh, that's different. Here's our 3 values. What's our first step to look at the what? Step 1, pH. Acidosis or alkalosis? Acidosis. Why? What's the match? Which other one is in acidosis? The CO2 level. What does that make it? Respiratory. Are the kidneys trying to help? Yeah, they're trying. They're out of whack. See, both things are abnormal. They're both out of whack. It is trying. The kidneys are trying really, 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 really hard by going more basic to pull that acidosis back in check. Are they doing a good job? No, because you're not normal. So this is partially compensated. Respiratory acidosis. They're trying. They're just not trying hard enough. Okay? Number 4. And I've got a whole set of more questions that are like a quiz in Blackboard for you to practice. You'll get plenty of practice on this. Trust me. Acid, alkalosis. Acid, alkalosis, acid, alkalosis. I do that every time. Doesn't matter how many times I do it. I still write them down like that. All right, 7.48. So it's out of whack. 51. Out of whack. 37. Out of whack. All right, so first step is pH. We are in, did I write that before? Yeah, okay. Make sure I had not skipped a page. We are in alkalosis. First thing we can do, because we look at pH, we're to the alkaline side. What's the match? Which one of these is the match? Well, this one's out of whack and causing alkalosis, right? That means this is metabolic. Alkalosis. Are the lungs trying? Yes, because it's not normal. Okay, but is the pH normal? No. So they're trying hard enough? No. Partially compensated. Metabolic alkalosis. Number 5. All right. Acid, alk, acid, alk, acid, alkalosis. Again, to me, it makes sense. You know, plug in the values, and it's just a plug and play. You don't even have to think about it. Just if the numbers match, you know what it is. 735. Ooh, that's weird. So 735 is the pH. The CO2 level is 48, and the bicarbonate is 39. So my pH, step 1, is it out of whack? Well, it's in the normal range. I Okay, so in this case, if it's on the line, you say it's toward the acidic side. So we're going to classify this as acidosis because it's on the acid side of normal. Okay, what's causing that? Which other one is on the acid side? The CO2 level, right? So this is respiratory acidosis. It's being caused by the respiratory because the 48's outside of the normal toward the acid side. All right, is the kidney doing anything? Well, it's not in normal range, so it's trying, right? And we see that it's at 39, so it's out of whack. It's working really, really hard. Has it pulled the pH to within a normal limit? Yes. Fully compensated. Do you see how that works? So your respiratory is out of whack. Your kidneys are going out of whack. They're trying to compensate for it, and they've pulled the pH back into the normal range. Okay? So fully compensated respiratory acidosis. And I bet you can guess what this one is. Okay. So, acid, alk, okay. pH 7, 4, 5. So it's to the alkalotic side. So we know this is going to be alkalosis. Okay. 49, which is toward the acidic side, out of whack. 31, which is toward the alkaline side. So what's the match? The metabolic. So metabolic alkalosis. Is it within the normal pH? Yes. Are the lungs trying? Yes. They are out of whack. They are trying really hard to bring that alkalosis back to neutral. So they're trying to bring it back to the acid side, and they've brought it back into the normal range. So that is fully compensated. Metabolic alkalosis. Those are your 6 problems. So you can watch this video as many times as you need to. I'm also, again, you're going to have some quizzes, and then you're going to have some practice problems. So you've got plenty of time to work on these. You will have problems like this on your exam. You can bring in a blank sheet of piece of paper so that you can write this stuff out. I do think it does help to write down these on your test and to work through it and figure out what's going on. If you have any questions, get on the discussion board and we'll talk about it. Thank you. That's it.